Well, this is kind of exciting because this is our last unit for the year. And it's on roots and rational exponents. We're going to be doing logarithms, but we're starting off with roots and rational exponents. Let's start off with our definition. Let n be an integer greater than 1. Then x is an nth root of k. In other words, x equals the nth root of k if and only if x to the n equals k. Now you might be thinking, what? I don't exactly get that. Well, think about it. If we say that the square root of 9 is 3, and remember square root means there's a little 2 there. We don't usually write it in. That means that 3 squared equals 9. That's all it's saying. Okay, so let's come over here to the cube root of 125. When we're trying to figure these out, these are ones that you would be expected to be able to do without a calculator. And what you have to realize is that if I'm going to give you one that's without a calculator, the answers are usually going to be somewhere between, I'd even say 2 and 7, maybe 2 and 10, but most of them are going to end up being between 2 and 7. So you have to ask yourself, what number when you cube it gives you 125? Well, anything that ends in a 5 is usually a hint that whatever its root is going to be has to have a 5. So the first one I try is 5, and I ask myself, is 5 times 5 times 5 125? Because it's got to be something cubed. Well, 5 times 5 is 25, and 25 times 5 is 125. So yes, the cube root of 125 is indeed 5. How about the the fifth root of 1/32? So think of this as the fifth root of 1 over the fifth root of 32. Well, the fifth root of 1 is easy. That's just 1, because 1 times 1 times 1 times 1 times 1 is 1. Well, we have to think of a number that when we multiply it by itself, 5 times gives me 32. Well, let's try 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is indeed 32. So it's 1/2. All right, let's go to this next one. X squared equals 1600. Have to take the square root. Now this time, because the square root was not there, I have to remember plus or minus. And I have to think to myself, what number when I multiply it by itself gives me 1600? Well, I know to get 16 I need 4, and to get 100 I need 10, so 4 times 10 would be 40. Let's think about that. Is 40 times 40 1,600? And yes, indeed, it is. So let's go to the next one. The fourth root of 16/81. So think of it as the fourth root of 16 divided by the fourth root of 81. So what number, when I multiply it by itself 4 times, gives me 16? Well, again, I always start off by trying my numbers. Like I said, most of my answers are going to be between 2 and 7. So start with 2. And is it 2 times 2 times 2 times 2? Does that work? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Yes, that works. Well, I know it's not going to be 2 for 81. Let's try 3. Let's just try it. 3 times 3 times 3 times 3. Well, I can see right here that 3 times 3 is 9, and this is 3 times 3 is 9. And I know 9 times 9 is 81. So that works. So the answer is 2/3. Okay, I'll start circling my answers here. All right, next one. Cube root of -27. So I need to multiply a number by itself 3 times to get -27. Well, it's going to have to be negative. I know it's not -2, because -2 times -2 times -2. I know it's going to be an even number. That would be -8. So So that doesn't work. So I know that it's not negative 2. So then I ask myself, what about negative 3? I just kind of go through my numbers. Negative 3 times negative 3 times negative 3. The negative part I know is okay, but 3 times 3 is 9, 9 times 3 is 27. Yep, that one works. So my answer is negative 3. But negative 121, the square root of negative 121. Okay, well, I know the square root of 121 is 11. 11 times 11 is 121. Negative 11 times negative 11 is 121. So how can I get a negative 121? It would, my only other option other than 11 and negative 11, what about 11i times 11i? That gives me 121i squared. Circle that, and that becomes negative 121. So that works. So 11i is my answer. Now, if they had said real number answers, this one would have had no real solution. This only has a complex solution. All right, let's go to the fifth root of 243. All right, again, I know it's not going to be 2, because when you multiply 2, you always get an even number, and this is an odd number. So the next one I'm going to try is 3. And let's see. I have to multiply it 5 times. So if you want, well, let's try to do it without a calculator. These are supposed to be non-calculator problems. I know that this right here is 9, and this right here is 9, and 9 times 9 is 81. And then I've got to ask myself, what's 81 times 3? 324. Oh, that gives it to me. There you go. So my answer here is 3. All right. The sixth root of a million. Because this has 6 zeros, then another way to write a million is 10 to the 6th. Therefore, the sixth root of a million is simply 10, because it would be, and if we want to write it out, we can, 10 times 10 times 10 times 10 times 10 times 10, which makes sense because there's 1, 2, 3, 4, 5, 6 zeros. So the answer is 10. The eighth root of 0, I hope we all know that that's just simply 0. Multiply 0 by itself any number of times, you are always going to get 0. Look at our next definition. When x is greater than or equal to 0, and n is an integer greater than 1, x to the 1 over n is an nth root of x. What that is saying is that x to the 1/n is the same as writing the nth root of x. This is how we can write it exponentially, and this is how we write it using a radical. Using exponents, this is written using a radical sign. They mean the same thing, which is why there's an equal sign in between. Right? So these particular examples here, like all of these up here, were written using a radical sign. These examples down here are written using exponents. So 216 to the 1/3 power means what is the third root of 216? So I've got to try. What's 2 times 2 times 2? That's 8. Doesn't work. 3 times 3 times 3 is 27. Not it. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 would be 64. I know it's not 5, because up above in that example I got 125, but I'm definitely getting closer. Let's try 6 times 6 times 6. 6 times 6 is 36, and what's 36 times 6? 6 times 6 is 36, carry the 3, 18, 19, 20, 21, 216. That's what I wanted. So 6 is the 1/3 216 to the 1/3, or the cube root of 216 is 6. All right, let's look at 1/36 to the 1/2. That means the square root of 1/36. So that's the square root of 1 over the square root of 36. Well, I know that the square root of 1 is 1, and I know that the square root of 36 is 6. So that one I didn't even have to think too much about. All right, this next one, I want us to be real careful here. This says negative 16 to the 1/4. But notice the negative 16 to the 1/4, the negative is not in parentheses, which means that the 1/4 is only applied to the 16, and the negative is applied after. This does not equal this. This is a different problem than that. I just need you to realize that, okay? So what we have to do is we have to figure out negative the 4th root of 16. That's what this means. So the negative sign is applied afterwards. So what number, when I multiply it 4 times, gives me 16? Well, we've done, after doing this a few times, I think I'm kind of starting to get the hang of this, but I can start with my 2's. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So I know that the answer to this part is 2, and then I apply the negative sign. So that's my answer. Now, if the problem had been negative 16 to the 1/4, that would be asking for the 4th root of negative 16. And that would be a different, actually, that would not have a real solution. Okay? All right, so that's how that would be written. But this is the problem that we had here. All right, we are not going to be doing the graphing. It's just one of the topics that we have to skip, which I'm sure you guys are not disappointed about. So we finished the first part, that first page. Let's go on now to our second page, where we're going to be looking at our properties of exponents. All right, so this page, sorry, just trying to make sure you guys can see everything clearly. I think I just made it worse. So I'm going to review these properties, and then we'll start applying them. So x to the m times x to the n, you have the same base. You add the exponents. For example, x to the 4th times x to the 2nd would be x to the 6th. Not x to the 8th, because you have to remember x to the 4th is x times x times x times x. X to the 2nd is x times x, which means we've multiplied x 6 times. So we just add our exponents. Well, therefore, division, if the base is the same. This is all if the base is the same. If you'll notice, we always have the same base here. This is going to be x to the m minus n. For example, if we had x to the 7th divided by x to the 2nd, we would have x to the 5th. Think about it. X times x times x. If I do it 7 times, 1, 2, 3, 4, 5, 6, 7, divided by x squared, 2 of them would cancel, and I'd have x to the 5th left over. All right, x to the m to the n, power to a power, you multiply. So when you have the powers, one power raised to another power, that just becomes x to the m times n. For instance, x squared cubed means x squared times x squared times x squared, which becomes x to the 6th. And we could have just simply taken 2 times 3. Okay. Now you have x times y to the nth power. You're going to distribute that exponent to both, so we get x to the n, y to the n. For example, x times y to the 5th would be x to the 5th, y to the 5th. x